quadratic functions in factored form, and we're going to expand some binomials to try and generate a connection to factoring simple trinomials. And I have a volunteer student who's going to volunteer answers. So we're going to work on expanding and simplifying expressions. So the first thing we have to remember is when we multiply two binomials, really what we're doing is using the distributive property twice. And this x gets multiplied with the x plus 7 in the second binomial, and the 3 in the first binomial also gets multiplied with the x plus 7. So we could rewrite that as x times x plus 7 plus 3 times x plus 7, and then use our distributive property and multiply through. And we see we've got x squared plus 7x plus 3x plus 21 gives me x squared plus 10x plus 21. And ultimately, we're going to look for a pattern here that allows us to go right from the two binomials to the answer. That's what we're looking for today. What is the pattern that exists that gets me to the final answer? So I don't have to do any work. In part B, we've got x plus 6 multiplied by x plus 3. Again, we're going to do the distributive property. I can take the time to split it up into x times x plus 3 and 6 times x plus 3. And that's a great step if I need it to help me. If I can go right to the next step by just drawing arrows and say x times x and x times positive 3 and 6 times x and 6 times positive 3, that's great. Now, I have to simplify because I have two like terms and I've got x squared plus 9x plus 18. Is there a connection between the 6 and the 3 and the x's in the original two binomials and the final trinomial? Go backwards and look at part A. Is there a connection between the 3 and the 7 in the final binomial? We're going to do another one. See if your connection is making sense yet. Again, x minus 6 times x minus 3. I could break it up into two distributive properties and then distribute. It's not necessary to do that. It does help for some of us to see the extra step and ensure we get the right answer. Some of us can go right to the line where we have this here. X squared minus 3x minus 6x plus 18, and I have my like terms, and I combine them. Again, is there a connection between the negative 6 and the negative 3 and the answer in the simple trinomial? X minus 4, x minus 7, same thing. X squared minus 7x minus 4x plus 28. Simplify. What's the connection? What do we see? Our two middle terms became one middle term. They were like terms. And when we added them, our middle terms were made from the numbers, negative 4 and negative 7, weren't they? And the middle term here was made from negative 6 and negative 3, and from positive 6 and positive 3, and positive 3 and positive 7. Those middle terms are all the result of adding the constant terms together. And then we multiplied by x. The first terms were all the product of the x's. Or sorry, the product of the x which appears in both binomials. And the last term, well, to get the last term, we just multiplied the constants. That was part of the distributive property. So there's a very simple pattern that exists to determine the trinomial that is the product of two binomials. Let's expand it a little further. If I take x plus 3 times x minus 7 and I use my distributive property, I end up with x times x squared minus 7x plus 3x minus 21. Is that the same thing? Could I have just said 3 minus 7 is minus 4x? Looks like it to me. Positive 3 times negative 7, negative 21. So it doesn't matter whether the signs are the same or opposite, does it? Let's double check here. X squared plus 4x minus 7x minus 28 minus 3x is negative 3 plus 4, negative 3. It is. So I've got x squared minus 3x, negative 7 times 4, negative 28. My volunteer student's not being very interactive right now. X minus 6 and x plus 5. Will it do the same thing? Can I just add negative 6 and 5 to get the coefficient of the middle term?
Yes.
Can I just multiply them to get the constant term?
If you do it correctly.
Yes. So we've got a pattern. It works, and it's always going to work. Now, the big thing I have to realize is I need to be able to go backwards. And that's what we're going to do in tomorrow's class. We're going to take what's called a simple trinomial, and we're going to say that has the form x squared plus bx plus c. Notice there are three terms. Unlike a quadratic, it has to have all three terms because it's a trinomial. It means there are three. The first term is the quadratic term, and it has a coefficient of 1. So there is no number in front of x squared. That's what makes it simple. The bx is the linear term, and it has to be there, and the c is the constant term. So our big thing for tomorrow that we have to think about tonight is how do we turn x squared plus 7x plus 10 back into x plus 2 times x plus 5. And we'll have lots of fun tomorrow in class doing it. It'll be very exciting. I know you don't believe me, but we'll have fun. And before you come to class, exercise 5, pages 9 to 11, I'd like you to try questions 1, 5, and 13.